Discrete Fourier transform. In this chapter, we'll discuss about computations in DFT.
Examples of DFT and IDFT equations. So let's take x of n equal to 8-point sequence, that is 10, 20, 30, 40. We have to find x of k. So by basic definition of DFT, x of k equal to summation of x of n wn raised to nk. Put n equal to 8 and wn raised to 1 is always e raised to minus j 2 pi by n. Expand this summation term. When we expand this, we'll get this. In this equation, x of 0 is 1, wn raised to 0 is always 1, x of 1 is 0, x of 2 is 2, wn raised to 2k, x of 3 is 0, x of 4 is 3, wn raised to 4k, 4, wn raised to 6k, and so on. Now this equation we have to evaluate for every value of k, starting from k equal to 0. So when k is 0, wn raised to 0 is 1, here also wn raised to 0 is 1, and so x of 0 equal to 1 plus 2 plus 3 plus 4, that is 10. To find x of 1, put k equal to 1, you'll get 1 plus 2 wn raised to 2k, k is 1, plus 3 wn raised to 4 plus 4 wn raised to 6 because k is 1. Here we'll have to substitute the value of Peeble factor, that is wn raised to 2, wn raised to 4 and wn raised to 6. We can refer that circle diagram and get those values. By evaluating this, we get x of 1 equal to minus 2 plus 2g. And this we have to repeat for k equal to 2, k equal to 3, k equal to 4, k equal to 5, k equal to 6, and k equal to 7. So always write final answer at one common place in matrix form, something like this. This is x of k. Now find the DFT of the following sequences. X of n is 1, 1, 1, 1. To find x of k, first we'll apply DFT formula, then we use matrix representation of formula, then we'll substitute the values of matrices, then matrix multiplication, and we'll get this answer 4000. Similarly, to find DFT of 100, we'll follow the same procedure and the answer is 1111. We can conclude something from this. 1000 is a delta n sequence and therefore DFT of delta n is always equal to 1. Whereas 1111 is u of n sequence and DFT of u of n is n times delta k, where delta k is 1000. If n is 4, 4 times delta k. When n is 8, 8 times delta k. Delta k is 1000. So find DFT of x of n, where x of n is 1, 2, 3, 4, arrow at 2. When arrow is not at first position, we cannot apply DFT formula, and then in that case, first you have to obtain DTFT, and then second step you have to obtain x of k, that is DFT. Summation of x of n e raised to minus j omega, n varies from minus infinity to plus infinity. Expand this summation term, you'll get this expression. X of minus 1 is 1, x of 0 is 2, x of 1 is 3, x of 2 is 4. This is x of omega. We can simplify it further by replacing e raised to j omega by cosine term and sine term, that is in rectangular form. Once we do this, we'll get something like this. So x of omega is 2 plus 4 cos omega plus 4 cos 2 omega minus j outside 2 sin omega plus 4 sin 2 omega. This is DTFT of x of n. When this DTFT is sample, we get x of k, that is DFT. So we have to replace this omega by 2 pi k by n. Here capital N is 4. So we have to replace this omega by pi by 2 k. Replace this omega by pi by 2k and you'll get this simplified expression of x of k. this equation we have to evaluate for every value of k to get the required value of x of k. So to start with k equal to 0, you will get x of 0. By solving this, you will get 10. Put k equal to 1. By solving this, you will get minus 2j, and so on. We have to evaluate this equation for every value of k.
Thank you.